Hello, everyone. It's time to move to next session. Next session will be in session 5. This session will be chaired by Dr. Francois. Francois, can you hear me?
Yes.
So please go ahead.
Okay. Good afternoon to everybody. I'm Francois Shin from the Institute for Infocomm Research, A-STAR in Singapore. Welcome to this session. Is on ICT related technology. And in this session, we have 4 speakers, 3 from Malaysia, 1 from Vietnam. Okay, so before we start, I'm not sure everybody is here for a photo session. Can I invite all the speakers in this session to turn on the cameras and we have a photo session? Okay, I move. So for every speaker, we have 10 minutes of presentation, 5 minutes of Q&A. During Q&A, questions, you may raise your hand for question, or you can directly ask the presenters. Okay, so the first speaker for this session is Mr. Mynn Teoh, and his presentation topic on the optical segmentation of e-colonies is for the development of IoT device water quality monitoring. So, Mr. Teoh, start your presentation.
Hi, very good evening to everyone. I'm Mynn. All right. So you can if there's any question, you can just raise your hand and ask me. So I'll be sharing my screen now. Okay. So can everybody hear me? Okay. All right. So today my research topic will be on the optical segmentation on E. coli colonies formed on specialized E. coli test piece. And this project is actually
I hear some breaking sounds.
Is it okay? Is my voice okay?
Mr. Teoh from ESM?
Yeah. Can everybody hear me perfectly? Okay. All right. So basically, for my part, there is actually a lot of is actually for development of IoT devices for the water quality monitoring system. Okay. So basically, the main reason of us creating this project is actually due to the limited water resources that is actually being an increasing problem globally. So while water reuse system is the only way to tackle this problem, many of these projects fail because of not proper monitoring and maintenance. So by using ICT technologies, we can have a real-time analysis and monitoring of the water quality. And by using advanced technology like machine vision technologies, we can determine the water quality and count the colonies of the E. coli or any kind of bacteria that is in the water instead of us human counting it manually. So one of the few problems that we face is that the technologies of the previous years is that we have to test the water in the big labs, but remote areas they could not access the lab so conveniently. So therefore, this is one of our problems that we found out during this project. And the second one is actually when handling the water sample with possible E. coli. When I say possible, it means that we are not sure whether or not E. coli is present. It's actually a very hazardous task, and it requires highly skilled personnel to actually run the test. And overall, the testing of water quality is not a smooth process. It's still very disconnected. We have to bring it from one area to another area, so it's still relatively disconnected. And after the test is done, the counting of the E. coli colonies usually is determined by a dot or many dots if there is a lot of E. coli colonies in the test piece. It is a very tedious process because lab assistants still count it using manual method. using a counter and maybe under a light and a magnifying glass. So to tackle all these problems, our solution is actually to design a portable machine vision system, which is actually in an enclosure. So it will be in a small enclosure and all the necessary sensors will be inside the enclosure. And then because of having the machine vision system, we also have to investigate the lighting effects on the colonies. All right, so this one I will explain a bit more later on. And lastly, to enable the automatic counting of the E. coli colonies on the test piece, we have to perform optical segmentation on the image that is taken in the enclosure. So therefore, the title, optical segmentation. Okay, so before we start understanding how the process is done, we have to first understand how water quality is determined. All right, so commonly, this is actually a common practice around the world. So water quality is actually determined by counting the colonies in a test piece. All right, so usually the unit for it is colony forming unit, or CFU per 100 ml of water. All right, so there is actually a standard to follow too, where we are determining the quality of the water. So like for example, the drinking water that we are drinking every single day, for safe consumption, it has to be 0 CFU, means that it's totally clean. There is no E. coli specimens inside the water, right? Therefore, actually on the left side here, we can see that actually to test the E. coli, we're actually using this specialized E. coli test film. So this one is actually only sensitive to E. coli bacteria, all right? So when it's if there's presence of E. coli, actually dots will form on the test piece here, the square part here, all right? Okay, so next, just now I did mention about the enclosure assembly. So basically, this is the enclosure. It's a very small enclosure which I have designed. All right, so all the necessary equipments, or rather, the whole process of testing the quality of water is actually done in this small enclosure. All right, so it starts from the incubation. So it starts from the moment we drop the test water onto the test film on this part here, just as I explained just now. All right, so it starts here. Incubation for it to form the dots on the test piece. There's actually incubation needed. All right, so the incubation process will be done inside the enclosure. All right, so it has to be run for 24 hours at a set temperature and a set relative humidity of 45% and the temperature of 37 degrees. This is the requirement for incubating E. coli bacteria, right? After that, the machine vision technologies, the sensors, the cameras, and even the lightings are actually residing inside the enclosure. So as you can see from here, this is actually all the necessary components. So the microprocessor, and then the camera, and also the lighting is inside. Okay, all right. So this is actually what we have done thus far. All right, the results are quite promising. All right, so this is actually the first step into the machine vision system. All right, so when we're talking about machine vision, one of the most important thing is actually a lighting. We have to vary different lighting to actually improve or make the dots here more visible, therefore having a more accurate E. coli count. Right, so as you can see here, we have done various testing on various lighting colors, and these three is actually one of the most obvious in terms of the difference. All right, so on the left is actually the control unit. So this is white, regular white lighting, which we can find in our regular household, right? And if you compare the red lighting and the white lighting, you can notice that the red lighting picks up more dots. So actually, like I said earlier on, the dots actually represent presence of E. coli bacteria, right? Of the E. coli colony inside. So as you can see here, the dots over here are is sharper and it's more apparent, all right? And then the blue, it couldn't pick up anything. So this is basically got to do with the wavelength of the various lighting colors, all right? So as you can see, red lighting is actually giving us the best results, all right? And we can verify the claim by using different softwares. Like for example, the most common one with ImageJ. All right. So as you can see from here, just by looking at it, the ImageJ picks up more of the dots compared to the white one. Okay. So as you can see from here, I've highlighted it for you. This is actually from a particular section of the test piece. So you can see here a few dots that is present on the red one is not present on the white one on the version, right? Okay, so lastly will be actually verification using the OSU method. All right, so this is done using MATLAB. So this is actually the red lighting for the red lighting, and this is for the white lighting. All right, so as you can see from the graph on the left, there is a great distinction between the foreground and the background. So there is a good comparison between because usually the dots will be on the foreground and then the test piece is actually the background. So there is a great distinction between the foreground and background. Therefore, the counting of the E. coli, the dots, the colony is actually more accurate. So as you can see here, this is actually for the white lighting version. There is no distinct peaks, all right? There is no peaks stating that there is no distinction between the background and the foreground. So therefore, actually, we can prove that by using red lighting, is actually giving us a better visualization of the presence of E. coli on the test cell, on the test piece, sorry. All right. So basically, that's the end of my presentation.
Okay. Thank you, Mr. Teoh, for your presentation. Any question from the floor?
Okay,
Anyone?
I got one question from hold on. Okay. So this one is actually, this design is actually to be used on the field, mostly targeted to remote areas where accessing labs to carry out water quality monitoring or testing is not available in that area. So this is where our construction or this system goes into play. Okay.
On who will use this technology?
Okay, all right. The next question, who will use this? So basically, this one be used by the water plants personnel inside. All right. So where remote areas there is no labs inside. So this is, and the lab workers are not on site. So basically, it's for general people like us. So anybody who has the access to the water source is able to use this device to actually to test the water quality of that particular area. Yeah.
Okay, this follow-on question. Any improvement to the
Okay,
existing
sorry.
film? Yeah.
Okay, so the film that we are using is actually, there is no improvement in terms of the film. The film is actually widely available in our market. All right, actually a lot of labs still use this film. What we are improving is actually the automation part. All right, so we don't have to, because previously when we are talking about counting E. coli cells or E. coli colonies on a test piece, usually we use a manual counter and we count it one by one using a naked eye, using our own naked eye. By using this design is actually to have to run everything automatically, therefore the use of machine vision system. All right, so the machine vision system is able to recognize and count the E. coli colonies on the test piece without human being there. So it's less tedious for us humans or the user of the caretaker of that particular water source. Yep. Okay.
Okay, thank you for the answer. Any other questions from the floor, from any participants?
There's a question in the chat. I don't know if it's been read.
Okay.
Hi,
Hold on,
can
huh?
I add on to my questions?
Yeah, sure. Please
Yeah.
go ahead.
So is it something portable, like something that is using you know, is it requiring power to actually run through things, etc.? Because that was not
Yes,
really clear to
this
me. Because you said it's going to be brought to remote, right?
Yes, this system is totally it's very portable. In fact, the entire enclosure is no bigger than your regular water bottle, and is run using batteries. And the microcontroller that is used inside is actually of a small size and is relatively low power. So you can run the entire test without needing of like a power source and so on. Everything is in the enclosure, and the enclosure is portable and is powered by rechargeable batteries. Yeah, and it's actually you can actually bring it around from one station to the other without worrying of any like power cords and so on. Yeah.
Because you can only look into E. coli, right? Because at the moment in Brunei, we are facing issue of manganese, because it turns the water brown. So despite having treatment before, but because of the presence of the, I think it's manganese, it turns the water brown. So can it be improved to that level as well?
All right. So for this part, is actually the answer is yes, but there will be requirements, there'll be changes need to be done to the algorithms. All right. So for now, the one of the main problems of water is actually E. coli. E. coli is actually the main cause of a lot of sickness, like the most common will be diarrhea and so on. Yeah. So if there is a need to detect other kind of bacteria, yes, it can be changed. Maybe there is a need to change the test piece or something like that to be, because like this test piece is only sensitive to E. coli. If there is a test piece that is suitable for the magnesium that you are mentioning just now, yes, it's able to do that as well. Right.
Okay, thank you.
Thank you for the Q&A. Thank you, Mr. Teoh. Let's move on to another presentation.
All right, thank you.
Thank you. The next presentation is by Mr. Keat. His presentation title is Development of IoT Water Quality Monitoring System. Okay. Mr. Tay, please.
Okay, thank you, Dr. Francis. Okay, yeah, can you all hear me clearly?
Yes, we can.
All right, thank you. So I will share the screen right now. All right, can you all see the screen right now?
Yes, we can.
Okay, all right. So good evening, everyone. My name is Keat. So I'm from the Universiti Sains of Malaysia. Okay, so my project title was the development of IoT water quality monitoring system. All right. So this project was actually a collaboration project with some of the experts from my universities, Dr. Yu Gohua, Dr. Yen Kin Sam, and Associate Professor Dr. Liu Choping and Miss Hong Chia Hui. All right. So I'll be the presenter today to show you guys what this project is all about. So just a detour from the project title. So as just now we had a question on how to detect the magnesium problem, right? It actually can be solved through this project. So I will slowly show you through this project and see whether it convinces you or not. All right. So the purpose of my project is to develop a system which can perform real-time monitoring system for the water reuse system. Then the second purpose of this project is to collect critical water reuse data to improve household water use and water conservation purpose. So then why I need to do this project? So the background of this is, as water demand continues to increase across the globe, the availability of potable water continues to decrease, arising from climate changes and limited water resource. So what do I mean by limited water resource is the water resource around the world, yes, there's a lot of water, but when you talk about usable water, it's actually really limited. So that's why due to all these factors, our water it becomes a problem where how we can obtain this usable water. So lack of sustainable water management on the urban water system also make us kind of hard to get this usable water. So accounting all these factors, water reuse system seems to be one of the viable solution. So there's a lot of water reuse project developed around the world, but many of these projects has failed because of lack of monitoring and maintenance. So that's why. So my objective of the project is to integrate the water quality sensors and performance of water quality measurements. So the second objective was to send and store the water measurement data in cloud storage. All right. So this is some of the standard imposed in Malaysia. So I obtained this water quality standard from the Department of Environment of Malaysia. So basically in Malaysia, there are 5 classes of water quality standard, which are class 1, 2, 3, 4, and 5. All right. So each class is split based on their tolerance of each of the water parameter, and each class has a different usage. All right. So yeah, this is the continuation. All right. Okay. So right now I will give a brief overview of my IoT water quality monitoring system. So my system consists of the water level sensors and turbidity sensors. Originally, I plan to integrate. We plan to integrate more sensors like the pH sensors and conductivity sensors and total dissolved solids, or we call TDS solid sensors. But due to some issues on the delivery issues, so we are unable to obtain those sensors and start to develop our system. All right. So then all these sensors are connected and controlled by the microcontroller, which is the Arduino Uno Wi-Fi Revision 2 board. All right. Okay. So basically, I will show you. This is my flow chart for the working mechanism of the IoT water quality monitoring system. So basically, we have a filter water here. So it will measure the turbidity and measure the water level by these sensors. Then these sensors will send the data to the Arduino Wi-Fi board, and this board will upload the data to ThinkSpeak. All right. So since the data is stored in the cloud server, the data can be easily accessed anytime, anywhere. All right. Okay. So this is the type of sensor that I have used for the system. The first one is a DF, the DF robot non-contact liquid level sensors. So it uses water sensing capacitor to detect the liquid level. So when there's no water, there will be a presence of distributed capacitance. So this results in a certain amount of static capacitance to the ground on the sensors. But when there is liquid near the sensors, the parasitic capacitance on the liquid will be coupled to the static capacitance. So the final capacitance will be larger, so the controller board will be able to detect it. So to more simple term is, this is the first, as you can see the first diagram, this is normally when there is no liquid around the sensors. But when there is liquid around the sensors, as shown in the second diagram, is an analogy when I have a finger like a water it will contribute some of the capacitance and add up in the total capacitance. So the control board will detect the extra capacitance and say, oh, this got water. All right. So yeah. Then the second sensor used is the DF robot turbidity sensors. So basically, it uses light to detect the suspended particles in the water. So beams of light will be produced from the photoemitter and need to pass through the water before it reaches the phototransistors. So the cloudiness of the water will affect the amount of light received at the phototransistor. It will then affect the voltage that is allowed to pass through. The voltage value is converted to NTU in the coding. All right. So basically, this sensor measures the turbidity. What we meant by turbidity is the cloudiness of the water. If the water is very cloudy, means the NTU is very high. All right. So this sensor will detect it. So when there is a higher voltage produced from this sensor, we know that the NTU is lower. Okay, means the water is clearer. All right. So this is the relationship between the turbidity and the voltage. So yeah, this is the equation governing the formulas between the turbidity and the voltage. All right. So right now, the quality monitoring system that I have done until now. All right. So how we upload the data to ThinkSpeak. So right now I will show you a video on how to upload the data to ThinkSpeak. All right. Okay, I'll play the video.
Hello.
Yes. All right. Yes. Hello. Yes.
Hello.
Tony,
Is
are you playing your
can you hear
video?
me?
Yeah.
Yes, we can hear you, Tony.
Sorry.
Right.
Mr. Tay, have you finished your video and or presentation?
Oh, I haven't. Can you all cannot hear the sound?
We can't hear the sound.
Oh,
No, we
I
cannot.
thought I share. Oh, but I thought I'm sharing the sound right now. Sorry about it. Okay. So sorry about it. Never mind. So I will just proceed because this one I just want to demonstrate how I upload the data. All right. So never mind. I will just roughly go through it. So basically I done the coding for uploading the data using the Arduino IDE, and this is how I connect it lah. All right. So so sorry for the technical issue. So I will continue the rest of the presentation. So sorry about that. Okay. All right. Then I will have, okay, this is the turbidity measurement that I have done for the known turbidity samples. So this is the reading I get. Right. So for the clear drinking water, I have a negative something. So the 675 NTU, I got 2000 something, and 413 will be 700 something. All right. So I know there's still some accuracy to be maintained. So because this project is still under development, so we'll have to calibrate the sensors to the standard that is established in the world. All right. So that's all for my project. And to just spare me one more minute. So this project is the output of the ASEAN IVO project and IoT water reuse in developing cities and financially supported by ICT. All right. So that's all for my presentation. Thank you.
Okay, thank you, Mr. Tay. Any question?
Yeah, I have a question. Can I ask the question, please?
Yes, please.
Okay, Mr. Ying Keat.
Yeah.
I am also a bit confused about what you are doing actually, because you connect the sensors, right? Like turbidity sensor, and then some other sensor.
Yes.
And you connect to Arduino Uno.
Yes.
Okay.
All right.
And then from Arduino Uno, you connect to the ThinkSpeak or something like that. Right?
Yeah, that's a cloud server. Yes, correct.
Yeah. What is the specialty of this project actually? Because if you just connect all these existing products in the market.
All right. So what what is so special about this project is because there's a lot of water reuse system, but a lot of water reuse system has failed because lack of the maintenance and monitoring. So that's why we try to solve this issue to make all these water reuse project success. So we try to deploy the IoT water quality monitoring system to all these water reuse system so that it can remotely monitor this water reuse system. Yeah.
Okay. Okay. Anyway, what is the difference between your product and the other one? The first one.
Yeah,
So from
actually we are actually connected projects. So for just now, Mr. Teoh will be in charge of actually on the organism part. So he will be actually detecting E. coli for now. All right, maybe there will be further organism can be detected in the water, maybe. All right, so we are actually a connected project. So I'll be in charge of monitoring those water quality parameters such as turbidity, pH, and TDS, conductivity. Yeah, all these parameters are extremely important to determine the water quality. Yeah.
Okay, last question. Is this a final year project or is this something else?
All right. Actually, this is my my internship project.
Internship project. Oh, okay. Oh, that's why.
This is my
okay.
project.
No other questions. Thank you.
All right.
Yeah.
Thank you.
Okay, thank you. Any other questions from anyone?
Hi. I would like to know, because you're using these Arduino sensors, these sensors are basically like a plug and play. So have you ever tested it in the long run? For example, if you're going to immerse it in water for a long time, how is the sensitivity? How is the, will it be affected throughout times, etc.? Have you looked into that? And how would you propose to put this solution in the real deployment?
Yeah. So to address your question, that is why I would say this project is still under development, and our next step was actually to expand on like because the next problem we see is like what Miss Vida said about I would say when you put all these sensors in long run in this water reuse system, there's actually one thing we'll call biofouling will occur. It will be it is a condition where a biofilm that will grow on these sensors. So we are trying to address that problem, but we haven't have any results because that one is the continuation of this project. Yeah. So but sadly to say we have no result for that now. Yeah.
Okay, all the best. Thank you.
Okay, thank you.
Okay, thank you, Mr. Teoh. Let's move on to the next presentation. Okay, by Dr. Muhammad Razali from the University of Tun Hussein in Malaysia. You're speaking on the IoT reverse vending machine for improving the recycling.
Okay, let me share my screen first. Okay, so first things first, my voice is okay? Hello?
Yep.
Yeah, okay. So thank you very much for the introduction. So my name is Razali Tomari. I'm from the Universiti Tun Hussein Malaysia. So basically today I will present in terms of my project title of development of IoT reverse vending machine and its feasibility study to improve recycling. So basically the presentation will consist of the two parts. So the first part will be I will explain about our machine that we developed, the components involved, the system configuration, and how we send data to the server. And then the second thing is that I will share with you our finding when we test pilot our system in two state in Malaysia. So basically in the future, you can see this is our journey in developing this particular machine where we test that thing, where we, let's say, join competition and etc. So one of the motivation of doing this project is based on this problem statement. So basically, statistically, it's about the 480 billion of plastic bottles were sold worldwide. But yet, from this particular figure, only 20% of that particular numbers was actually recycled. So leaving the rest in actually in the ocean and can be in some sort of the landfill. So in terms of the nature of the plastic, so one of the recycled items is that for the plastic, it requires around 500 years to naturally break down. And then one thing that we can solve this particular issue is that we need to perform the recycling process, in which for the recycling, we can, instead of relying on the raw materials, we can use the recycled items in order to develop a new product. So in that case, it supports the concept of the economic recycling. So one of the things regarding the plastic sinisters is that if that particular plastic bottles that enter our body, so it can cause some sort of disease. For this particular case, they said the lung problem, the liver dysfunction, and etc. So one of the things that we try to emphasize is that we want to develop a system that's capable to improve recycling in Malaysia. So in general, for our local issue is that the recycling rate in our country is around 70%. And then this is some sort of the two current practice in order to perform recycling. The first one is that the user can actually dump the recycled item in the dedicated recycle bins. And then for this particular case, they don't get any reward. The second thing is that they can accumulate that particular waste and then bring that thing in bulk to the recycle center in order to get a reward. But currently in Malaysia, in terms of the recycling rate for the plastic is around 20 cents per kilogram, and then for the aluminum can is around 2 ringgit something. It's quite good. So what we do is that for this is some sort of the statistic of the recycling rate around the world. So one thing that I want to emphasize from this figure is that first world countries such as the Norway, Sweden, and Germany, they show the highest percentage of the recycling rate because of their incentivized people for the recycling, even with the smallest amount of the recyclable items. So in that particular country, they have some sort of they call it the container deposit scheme. So for this particular case, let's say, for instance, let's say if we buy the mineral bottle, let's say $2, so 20% is the thing that you can get when you return back that particular bottle to the vendor. So there is the concept of the container deposit scheme. But yet in Malaysia, the scheme still not yet implemented. So one thing that we try to improve, boost the recycling activities is by introducing the concept of interactive machine and concept of collecting point, which is we call that thing as the give a reward for the user that are able to perform the recycling practice accordingly. So for this particular case, this is some sort of the company that implement the recycling activities in Malaysia. So you can say, let's say iCycle or Recycle for Life. So this is some of the company that develop the apps in order for the user to collect the point, and then based on the collected point, they can redeem something, let's say some sort of the goodies or some sort of the reward in terms of the monetary. And then the second thing is in terms of the second one, let's say for the Monji and RVM in Kuching. So for the Monji, they develop the system in which when the user recycle, they can actually play game on site, which is the game was actually put in the RVM machine. So this is some sort of the solution worldwide in order to develop the interactive recycling process, and then at the same time provide a reward to the user. So this is some sort of the reverse vending machine that can be found in the USA, in India, in Thailand, Korea, Norway, and etc. So basically, based on that, the things that have been developed in Malaysia and developed worldwide, we propose to develop our own custom-made reverse vending machine. So one thing that we want to highlight in terms of our machine is that it will be fully custom-made. So means that we develop something that is based on the requirement of the customer. So let's say they want whatever type of shape, they want whatever type of redemption they want to put in the system, and then whatever process flow that they require, so we will develop that thing. So basically, our system consists of the machine, and then we develop our own dashboard. So for this particular case, we have two types of dashboard. The first one for the admin in order to monitor everything, the process, and etc. And then the second thing for the user, which is they can view the accumulated point, the transaction log, and etc. Then they can use that thing in order to redeem a reward. So one thing that we want to highlight regarding our system is that our system is in terms of the modular configuration, which is we focus our system in terms of the smallest part of the module, which is the small module can be actually plugged into anywhere. Let's say behind the wall, whatever casing that the customer required, we can plug into that thing. So this is the thing that we emphasize in our project, which is we develop our own custom-made modular, which is this is the important part that will be utilized in order to identify the recycled item. So this particular chip will receive the recycled items, and then later on it will identify that thing. Later on, a diverter will divert the corresponding recycled item to the dedicated bin. So basically, for the chip that we have developed, so this is type of sensor that we use. So basically, in general process, we use the inductive sensors in order to detect the aluminum can. We use the combination of the capacity sensor and also the laser in order to detect the transparency level of the PET bottle and then the capacitance value. And then later on, we use the combination of the ultrasonic and also the infrared sensors in order to detect the presence of the recycled item inside of the chute before performing the material identification process. So once everything is in line, is good, and then it will send the log to the mini PC. So mini PC will actually transmit all the information to the database. So for this particular case, we use the SOAP protocol, Simple Object Access Protocol. And then for this particular payload, we use the XML type of the payload. So this is basically some sort of the snapshot of our system. So in the left side, this is actually the console where the admin can actually configure in terms of the how many points can be collected for each of the recycled item, and then they can actually adjust that thing accordingly because of usually in terms of the rate of the recycling will be actually changed by day, month by month, and etc. So in the right side is actually the transaction log of the bin. So this is we extract the thing from one of the recycled item that we put on site. So this is the result that I want to show in terms of our machine. So this is the simple video of our machine. So basically you can view most of the details of the video in this link, bit.ly rvm. So this is some sort of the process for the user in order to utilize this machine. They need to touch the screen, and then inside the recycled item, material identification will perform, and then the amount will be shown here. And then later on, when the process is actually completed, they can press stop, and then the barcode they can utilize in order to redeem the point will be given to the user. And then this is some sort of the repetition of the process. The same thing, they put another item, material identification process, and then later on, the barcode will be generated in order for the user to claim the redemption and etc. So this is what I want to highlight in terms of the second part of my presentation, which is we have put our machine into location. The first one in the Cyberjaya, which is for that particular machine, we put it indoor. And then the second thing, we put one of the machine in Batu Pahat Municipal Office, which is for this, but for the second part, we put that thing outdoor. So we want to know the user perception level in terms of the machine, or it can be used in order to increase recycling activities or not. So basically, this is our finding based on our machine for 3 months in Cyberjaya and also 3 months in Batu Pahat. So basically, for the first prototype that we put in the SW Corp Cyberjaya, so most of the time the machine will be used by the SW Corp staff, in which they utilize the machine. It's quite freely occupied. So one of the things is that they highlight the problem of the machine is in terms of the technical issues. So the first one is some of the item stuck inside of the chute before entering the final bin. And then second thing is that because of this is the recycled item, so and they put that thing indoor. So one of the issue is that there will be quite smell in terms of the recycled items. And then so finally, as the conclusion, we can conclude that RVM is enabled to extract the recycling activities, and then we can improve the system by introducing the vision system, which is in this case we train the model by using more recyclable item, and then we put the old camera in order to perform the process. So thank you very much for your attention to my presentation. Thank you.
Yes, thank you, Razali, for the presentation. Any question from the floor? Razali, just now I understand from your findings, from the cans, you mentioned there is like coffee smell. How do you want to solve that issue?
So actually, what we do is that so we need to do the cleaning for, let's say, every week. And then second thing is that we put the ventilator in order to, let's say, of course, it will be some smelly outside, but actually the smell will not accumulate it inside of the particular bin for implementation. So, but that is one of the issue if we use that thing indoor. But actually, when we put that thing outdoor, so we don't have any issue regarding the odor of the recyclable item, especially from the coffee container. So it's quite strong compared to other type of the recyclable items.
Okay.
Can I ask a question?
Yeah,
Please go ahead.
You showed the main component basically that you want to sell is basically the sheet, right? But as you show in the picture forehand here, there are some structure like a box and then cards and then as we know, cans, they have different shapes nowadays as well. So how do you into that? Because as you can see, your is actually in home, right? Something that can detect this is a can, this is a stick, this is a Tetra Pak. Is that mechanism there?
So actually, for the improvement of the mechanism, so because of there is some request in order to let's say identify the Tetra Paks. So actually, for the Tetra Pak, in general, it enables to use this particular type of system. So we need to use other systems. So for this particular process, we are developing the conveyor. The mini conveyor in order to handle this particular case. But you are right, actually, for this particular tube model, so it able to, let's say, aluminum can and PET bottle, but enable to handle the Tetra Pak because of Tetra Pak enable to slide properly inside of this particular PVC container. So one of the solution is that currently we're developing the mini conveyor in order to make the things much more smooth in terms of the flow of the recyclable materials.
So what about in terms of detecting whether it's a can and then there are several type of cans, right? Sometimes it's aluminium, sometimes it's not aluminium can as well. And because if you can see, Red Bull is a bit sturdy in terms of the can compared to the Nescafe or Pepsi tins. So does it also detect in terms of that as well? Or
okay, so for the previous system, we have that particular issue. It means that we're able to differentiate between these two type of the material. But currently for the improvement, since we use the camera, so we train that thing, everything. So we train every type of particular can, every type of the particular bottle and etc. So that thing, in terms of the output of the classifier, it can be either specific particular model or it can be general things. So there is some sort of the improvement for that particular thing. Means that they say Red Bull, whatever Nescafe, right? So for that particular case, we in terms of the training, we put that thing in terms of two type because of usually for our case. For the Coca-Cola, they want only that particular material to be recycled to them only. So we developed specific dimension for Coca-Cola. So the improvement currently we are in a process to developing the vision type of model in order to ensure that we are able to handle much more type of recyclable items.
But don't you think by adding the vision, it will cost more? And as you mentioned just now, some users actually just require a specific things. So it actually, I don't know what in terms of ROI, in terms of cost, will that be something more beneficial, or rather you can actually look into the maximum size that this particular recycle bin can actually accommodate, you know, because it has to reach a certain time, a period where it's already full. So you have to inform someone to clear it up, something like that.
So in terms of the, let's say, the costing, right? So currently we use the one camera. One camera is cost around, in ringgit Malaysia is around 300. Let's say USD is less than 100 USD. So it's quite cheap. So actually, total cost for development of the machine in ringgit Malaysia is less than 3,000. It's quite cheap. Let's say you can see around less than 1,000 USD, something like that. Okay, but we are in the process to make the things much more affordable by using the vision system to make it actually more flexible in terms of the user requirement.
Thank you. All the best.
Okay, thank you.
Okay, thank you, Razali. Let's move on to the last presentation for this section, okay, which is titled Autonomous Drone Swarm for Drug Delivery in COVID-19 Pandemic. And this will be presented by Mr. Nguyen from Vietnam. Please.
Good afternoon, everyone. Can you hear me well?
Yes, we can hear. Can you turn on the video?
Okay, I will start.
Yes, we can see you. Please go ahead.
I'm Nguyen. I'm from the LQDTU Technical University. in Vietnam. Now I present our proposal with the title Autonomous Drone Swarm for Drug Delivery in COVID-19 Pandemic. Firstly, I will introduce briefly about the proposal. As the COVID.
Excuse me. You are currently not sharing your screen.
Sorry, wait a bit. Can you see my screen?
Now we can see.
Yes.
Yeah. Yeah. And also maybe you need to speak a bit louder. Thank you.
To add corona appear from the end of 2019 in China is spread quickly over the world.
Sorry, can you put to the full screen, because now we see two screen. We see the presentation screen with the text.
Okay. Can you see the second screen?
We can see the screen. Yes. Yes. Okay. Now we can see it. Thanks.
And to reduce the outbreak of COVID-19, the best way, as we know, is to keep the social distance. Right? That leads that leads to new ways for delivering food and medicine instead of the traditional delivery service. So that raises the application of drone for safety delivery service. I studied that two main possible use case use a drone. Its first application is transportation, medicine, or food, and second is the can use for the area spraying of public area. First one it can use for the public spray monitoring or guidance during the lockdown. However, the current drone system may be a little bit need to improve for the navigation accuracy as well as delivery scheduling. So in this proposal, we want to propose a new solution for the autonomous drone swarm. It for the smart delivery. It includes two new techniques and new advanced technique. Is first is the propose a new autonomous navigation using the computer vision and the advanced vision, advanced deep learning. The second is propose a new way for optimize the delivery scheduling. With targeting to minimize the transportation time, energy, and payload and many objectives. Second target in the proposal is to contribute to capacity building the Asia region. And after that, we can have to develop the existing link and establish new link for researchers for Asia, Korea, and Japan. So now I introduce a little bit about why we need autonomous drone for the safe and in the COVID-19. When the COVID-19 the experience appear that we need to keep the social distance very well. But however, all people need food and medicine to teach them, right? And so, but traditional delivery service assists the potential danger of the virus infection. So the safety delivery service apply the high advanced technology for food and medicine necessary. With the advance of AI, so it can provide a good tool for smart delivery, smart navigation, and how we can optimize the delivery schedule. So the requirement for the firstly is the drone should be localize itself in the environment. And secondly, in the drone swarm, when the system receives a site of delivery, the system should be assigned each drone smartly in order to optimize the multiple objectives like the energy, weight, couple of transport. So even though there are systems or several systems already developed, but we still need some autonomous navigation accuracy, optimize the path for each drone. So to develop to prepare for this project, our team already studied and published a paper in in this paper, we present an accurate localization methods for transportation accuracy of 1.4%. It's possible to apply for this autonomous drone swarm with addition improvement. So here I show some the main part of our methods. Get the picture. We radio camera and extract the picture and match between them. And the good match can be used for input for optimize pole optimization. And each frame to frame pole add up by it the current vehicle internal reference frame. So in now we study to try to replace the component of traditional SLAM by deep learning model. That means as you see in the we try to replace some part of geometric value upward by the deep learning upward in the bottom like this. So in this project, we will provide some background of the drone technology, computer vision, and deep learning approach for autonomous drone navigation and related technology. And the result will be present and published in some conference and journal paper. It can be applied for patent or collaborate with the industry to transfer the technology to society. to succeed the project, we will follow some methods. We need to do some surveys on the autonomous drones one and some current and ASIC solution to clarify the detailed requirement for implement mass delivery service beyond the drones one. And beyond the limitation of existing solution, we will be propose the innovative and new solutions. The mass delivery service beyond the drones one, with the two one the efficient drone navigation using the multiple model deep learning and on the data capture from the multiple sensor. The second is the multiple objective optimization for the optimal delivery scheduling. We also project in this proposal, we want to collaborate with different partners to share the knowledge. And
can you wrap up in 1 minute? So we have some time for Q&A.
So I can make conclusion now. Smart delivery is essential tech for delivery food and medicine, especially in the COVID-19. And develop AI can provide efficient methods for autonomous navigation, as well as the fast scheduling in the smart delivery system. So, okay, that's all I have. I already finished.
Yeah, thank you for the presentation. Yes, we have some time for Q&A. Anyone?
Hello.
Yes.
Yeah, I can try to ask something. Who will be the user of your system?
Who
will fund you? Who will give you money to build this?
Actually, we try to make the initial study and by ourselves. This support by our university right now.
Yeah, but after I actually this type of application is useful, right? But to be able to make use of it, there must be a scale, a certain scale that it can be useful. So, but to drive to that scale, how to start that?
Actually, we will start from the.
Yeah, so when you put your proposal, I think you need to address that when you write in the proposal. Yeah.
Yeah, actually, firstly we try to make some initial study first. After that, when we have enough the skill, we will start to develop the real one, I think.
Yeah, the technology itself should be achievable, right? You just need traffic management, route planning. Although I think it's achievable, but after you have it, how to deploy it, and there must be a people who are willing to invest into it.
Yeah, sure. Actually, further. We try to get some funds for this project recently, but we need to wait for some kind of
Yeah. Good luck. Yeah, for your proposal. I think you should try to make this part a bit clearer for the proposal.
Yeah. Thank you.
Thank you.
Yeah, thank you for the comment. Yes, maybe one last question from Tony Anwan.
Okay. My question is, what kind of drone are you planning to use for your system?
Drone is some kind of look like the robot. It can fly. It can fly in the air, right?
Yeah, drone is something like robot which can fly. Yes, but what kind of drone? Is it how many kilo, for example?
Yeah,
what is the weight of the
the weight
drone?
and the size of the
The
drone.
size, yes.
Yeah.
Are you planning already?
I'm not planning right now, but we maybe plan with some kind of a little bit heavy drone, or it can be have to enough the possible can be.
Yeah, you must plan well because there are drones which cost you like $500,000. Yeah? So if you get from an ICT like that would not be so beneficial for your project.
Yeah, actually, we didn't decide which one we will use.
Oh, okay. Okay, thank you. Thank you, Prof.
Okay, thank you, Hung. Thank you for all the informative and interesting 4 presentations. If you have further question, you can send the question to the presenters directly. And let's have a 5-minute break before we move on to the next session. Thank you.
Okay, thank you very much.
Okay, thank you.
Thank you, Prof. Francois.
Thank you, Dr. Francis and the speakers.